The first thing to know is that there are a lot of time intelligence functions in PowerPivot. In fact, of all of the new functions that PowerPivot introduces to us, formula functions, time intelligence makes up for the vast majority of those. And to illustrate that, let's pretend like we're creating a new measure and bring up the function list and set it to the date and time category. And I don't believe this dialog is resizable. Oh, it is. Good. So you can just see as we scroll through here that most of these are things that we've never seen before, at least not in regular Excel. Some of them are familiar, like today, for instance. But most of them are brand new. I think there's more than 40 of them. And that might seem a little daunting at first, but the good news is that there's really only a small number of families of these functions that all kind of behave the same way. So like, for instance, you can see dates MTD, dates QTD, dates YTD. Those are all going to behave very, very similarly. So it turns out there's really only a much smaller number of concepts to learn in time intelligence. And most of them, actually, the bulk of what we need to know about them is already, we've already covered in terms of filter context, measure evaluation, and things like that. So yeah, this isn't going to be bad. It's actually going to be pretty exciting. But before we really even get started with time intelligence, the first thing we really need to do is we need to make sure that we have a calendar table. So let's go over to the PowerPivot window, and it's not necessary that you call it calendar. You can call it whatever you want. The name of the calendar table is not important. I always call mine calendar because it's just habit. But anyway, the key characteristics of a calendar table are that, first of all, it has a date column of actual data type date. Secondly, that date column must be unique, meaning a given date only appears one time in the calendar table. There are no duplicates for a date. The third requirement is that there be no gaps in the calendar table. So if your business doesn't operate on Sundays, too bad. You still have to have the Sundays in your calendar table. If you have gaps, you're gonna have problems. The other things that you should make sure of are that your date column is truly a date column and doesn't have any time values in it. So you see that I've got 12 a.m. all the way down here, and 12 a.m. is essentially 0 in the time component. So if you don't have any time in your your date time field, it's going to show up as 12 a.m. So 12 a.m. is good news. And I leave it formatted like this because I want to be able to see if something sneaks in and I actually start getting real times in here, like 3 o'clock in the afternoon or something, because that can cause us some serious problems. And it's very mysterious if you can't even see it. So it's tempting to change this format here just so we don't have to see the time value, but I leave it in. And I highly recommend that you leave it in as well. The other thing is that you want to make sure that this date range covers sort of the min and max date in your calendar table. Make sure that it covers the dates that matter in terms of your data tables. If you've been conducting transactions in the year 2009, well, you better have 2009 included in your calendar table, or otherwise you're just going to be getting blank values like on the rows of your pivot table, for instance. And there's a lot of different ways you can have the calendar table can extend farther than your actual data tables do. So you can leave some room in the future. We'll see over time that there's that introduces a couple of little wrinkles, but it's not a big deal. But those are really the main things, is that it has a unique column of date type with no time values in it, and that there are no gaps in the calendar table. Okay, so we could do a whole section as well on how to generate calendar tables. Maybe we'll do some of that in the bonus material, but I'm not sure we'll have time. So there are many ways to do it, and I'll at least reference some blog posts and tools that can help you with that. Okay, so the other thing that we should do with our calendar table before we get started is on the Design tab, there is a Mark as Date Table button. And we've been operating so far throughout the whole course up until now with our calendar table not marked as the date table. And we've survived, haven't we? But from this point forward, we definitely should have it marked as the date table. And even if we didn't mark it as the date table, everything might be okay. We might start writing some measures, and everything will be working fine, and things will work fine just long enough for us to forget that we haven't marked it as a date table, and then you'll run into problems later that are mysterious. So I highly recommend that you always mark your calendar table or your date table as the date table as soon as you import it. I didn't do it because I wanted to be able to show you what it looks like to set it. But let's go back to Excel. Before I set this, let's go back to Excel and let's look at some things. So I have a date. I have calendar date from the calendar table on rows here. And if I do this drop down, you'll see that I've got label filters here. So it's basically treating the that date field as if it was text. It's not actually recognizing that it's a date type, because if it were, we'd see the special date filtering fly out here instead. So that's one thing that you'll notice before you've marked something as a date table. And then another thing that you may notice, we've been noticing this quite a bit throughout, is that if I take month, English month name, for instance, and put it on the pivot table, it sorts alphabetically. Again, no recognition that these are months on the calendar. Okay, so let's go back to the Power Pivot window and let's mark this as the date table. And when you click this, whatever table you're on, so calendar in this case, that's the one that's going to be marked as the date table. And it's going to ask you, what's your date column? What is the column that fits those criteria we talked about earlier? Unique, doesn't have time values in it, doesn't have gaps. What is that column? Okay, so we're going to go ahead and specify that. It takes a second to apply all of its changes behind the scenes. All right, now we're done. And when we go back to Excel, we're going to see that Power Pivot data was modified. It wants us to refresh. And hey, we're still April through September. But strangely, if we bring up this row label and choose sort A to Z sort now sorts our months in the proper order. And you'll also see that we have the date filters fly out instead of the value filters fly out. So something has definitely happened here. Excel has gotten a lot smarter about interpreting what this data is. It actually knows that it's a calendar, and that's a big step forward. And it helps us in other ways too. In particular, with a lot of the time intelligence functions, they don't actually work properly unless that we have marked it as our date table. Okay, so I think this is a good place to stop this little segment, and then we'll come back and dive in with the DatesYTD function. Let's start out with some running totals, and specifically, let's start with a sales year-to-date measure. So I want a measure that tells me from the start of the year till now, or any particular point in time, actually, how much we've sold of whatever. For now, it'll be how much we sold of everything. So we have a total sales measure here, and I filtered, with the slicer, I filtered year down to 2002 so that we're only seeing 1 year's worth of data as a starting point. And we're going to create a new measure and call it YTD sales, year-to-date sales. And it is, of course, a calculate of total sales. That's the base measure that we're going to start with. And we're going to introduce, so we've seen a number of special functions that we can use in place of the normal calculate filters. We've seen the filter function, the all function, the dates between function. And now we're going to do the DatesYTD function. And DatesYTD tends to be the first one that I introduce. It's just that dates between worked so well into our disconnected slicers segment that I couldn't resist. But the things that we've learned about dates between will pay off with DatesYTD because there are some definite similarities between them. Now the DatesYTD function, it only has one input that's required, and it's another one of those dates inputs. And as I said last time, whenever we see that dates, we know that it's asking us really for the date column in our, what I call the calendar table, but what Power Pivot calls the date table. So we get really good at typing the name of our calendar table and the date column. We do that over and over and over again whenever we're working with these functions. Now I'm not going to do anything about the year-end date optional input. We're going to leave that alone for now. We'll hit that here in a second. So I close the DatesYTD function, and then I close the calculate function. Set this to our typical currency format, and let's see what we get. Okay, so in January of 2002, total sales and YTD sales are equivalent, and well, we should expect that. We would hope that those would match. And then as we go down further, let's say I select the first 5 months of total sales here, we'll see that we've got a sum here of 3.1 million, 3.128 million. And it turns out that's the number we're getting here. So this is a nice, smoothly increasing amount that is the running total as the year goes on. And the fact that it matches, so these 5 here add up to be this one, is, obviously that's the way that we prove to ourselves that it's working properly. But that is not the way that DatesYTD operates. It's not like there's nothing anywhere behind the scenes that is taking those 5 numbers in the total sales column and adding them up. Remember, measure cells in the pivot table are calculated as islands. So let's step through for this, the currently highlighted cell, the May YTD sales cell. Let's step through how the Power Pivot formula engine arrived at that number. Now, I made a new calendar to demonstrate this section, DatesYTD, because we're going to zoom in on just sort of the first 18 months in our calendar. But before we flip to that, let's make sure we know what our filter coordinates are coming in from the pivot table. So we have 2 of them. We have calendar English month name equals May, and we have calendar year equals 2002. So we have 2 coordinates coming in for that cell. And with that in mind, let's go over to the calendar. Okay, so May and 2002. Okay, so our initial filter context is exactly that. Between, so the 2002 selects all of these, and then May rules out everything but May. So between the 2, we end up with just this single month in our initial filter context. Okay, so what does DatesYTD do? Well, it takes within the existing filter context on the calendar, which is the highlighted month, it finds the very last date in that range. It finds, which happens in this case to be May 31st, 2002, okay? And then it rewinds from there, much like dates between, and goes all the way back to the beginning of the year. And it knows that January 1st is the first day in the year. So we end up with, it's going to be, basically the same thing as if we had done a dates between from January 1st, 2002 to May 31st, 2002. So we end up with all of those selected. That becomes our filter context. And then the total sales measure is evaluated as if those 5 months were all active. So we end up getting the sum across all of that, and that's why it matches the sums of the other 5 added together. But it doesn't. That's not how it goes. It's gonna run the sum once with those 5 months selected. Okay, one more time. DatesYTD. You start with the initial filter context from the calendar table, which is May 2002. DatesYTD looks for the very last date in that range and then expands the filter context from that last date all the way back to the beginning of that particular year. Okay, so we've done this now with month on rows, but does this work with other fields from our calendar table? You bet. So I'm going to take English month name off of here, and you'll notice that the numbers match right now. And if I go back to the calendar table, and let's just we can put date on here. We can do it by individual days. So grab a handful of days. They add to 167,040. This adds to, and that's what we get, 167,040. So year to date works with date as well. And then maybe we do week number of year. Let's put that on rows. So again, let's grab a range of weeks, 1.616, 1.616. Very nice portability. It's working across all of these things. I've also got a month year column that I've added to the calendar table, and so it builds the name of the year into the month. Notice that it's not sorting properly, and there's nothing I can do about that. I have to go and do the sort by column. It turns out that marking it as a calendar table isn't smart enough to sort every one of your columns appropriately. So I'll take care of that with a sort by column in a moment. But well, actually, let's go take care of that now. So we're going to add a calculated column. I'm going to shoot over to the right-hand side here, and here's the month-year column that we're using on the pivot right now. That's not sorting properly, and over here we're going to do the sort by column thing. Now, the reason why this is not sorting properly is just that Power Pivot is good at detecting that if a column corresponds to a calendar month, which is something that happens every year. August recurs over and over again every year. If it notices that this column has that kind of relationship to the date column, it will allow it to sort properly. But when we go year month, well, this is not really this isn't just a month anymore. Now it's a specific year as well, and for some reason that's too complicated for Power Pivot to figure out, and so it doesn't sort that one properly. So we have to write a sort by column for this one. And the temptation is to say, well, hey, I want to sort my month-year column by the date column. I mean, As date goes up, this changes, right? So conceptually speaking, this could work. But when I click OK, I'm going to get an error that says basically that for a given year, month, year, I've got a lot of different values of the date column, and it wants one value. It wants a one-to-one matchup between, for every different value of month, year, there can only be one value in the sort by column. So we need to do something else. It turns out that we have a year month numeric column, okay, and so let's use that instead, and that is going to work. Okay, so now back to Excel, do the refresh, and now we have to wake it up a little bit. I still don't know why that's not working. It turns out that my same old trick that I need to do when I add a measure or a calc column that's not showing up over here, if I create a new pivot table and put month, year on this pivot table, I don't even have to change the sort. It just works right off the bat. And so it's just one of those things where Excel was still remembering the old sort order, and I had to create a new pivot table to fix that. Okay, so I'm going to go ahead and put my measures back on here. I'll skip ahead. All right, back in business. And just to see kind of visually how this works out, I'm going to go ahead and set the pivot table option. I'm going to unset the auto fit column widths on update so that these two columns remain the same width whenever we make a change. Go ahead and center those to make it look a little better. And then I'm going to add data bars. So total sales, we'll call that green, and set the third option. So you see that it kind of fluctuates as you would expect on a monthly basis. And then over here we'll set another data bar, and this one will you'll see that it builds at least until the end of each year. So I've cleared the calendar year slicer, and so you see that our number gets larger every month in the YTD sales department until it hits December 2001, and then it resets and it gets small again. But then as we go, you watch this nice stair-step pattern every year all the way until the end. Now, let's look at one thing here let's get this out of the way pretty quickly. Why is our grand total at the very bottom of the pivot table, why is it 9.77 million? In some sense, maybe we were expecting a bigger number. I mean, we're doing about 9.7 each year. 2003 ended with 9.7, 2004 ended with 9.7. It should be, maybe 30 or 40 million maybe. But the way that DatesYTD works, again, everything's very mechanical in Power Pivot. This is the right number, okay? And again, to see that, let's go and look at the calendar. We need the bigger calendar this time. And I know that July is missing from up here, but just pretend that it's there for a moment. And the filter context in terms of the calendar for that grand total cell, there are no coordinates for that grand total cell. It has no filters whatsoever. So that means the entire calendar is selected, at least at the beginning. But when DatesYTD gets a hold of it, just like before, it finds the very last date in that range, which is July 31st, 2004, and then it rewinds back to the beginning of 2004, which is January 1st. So all of those, that becomes the range that the DatesYTD calcs over. And actually, I think we needed August in here as well, but it was really the end of August. So if we go, because we have that in our calendar, if we go back to here, well, actually, we don't have any sales in August, so I guess leaving August off is right in some sense. I mean, it did have August sent in. August is in the calendar. So for a completely unfiltered calendar, it is going to be the end of August. But anyway, this is why the grand total matches the YTD total for the most recent year. We grabbed the last date in this year, we rewound to the beginning of this year, and that's what we got. So again, very mechanical, just like everything else in Power Pivot. Now, I know I said in a previous lesson that I didn't think we were going to get into this whole topic about where calendar tables come from, as if it's some sort of impolite, inappropriate topic. But on second thought, I think I really just can't send you out into the world without explaining this to you, without sitting down and having a very serious conversation about it. And so we're going to have the dreaded talk about where calendar tables come from. And the answer is calendar tables can come from at least 4 different kinds of sources. And no, you shouldn't expect the stork to bring you a calendar table, and you should never expect to find a calendar table hiding in the Cabbage Patch. The short answer is you're generally going to have to make them or have someone else make them for you. So the first kind of source is to get your calendar table from a database. And the more sophisticated your organization becomes in terms of Power Pivot adoption, the more likely that you're going to ultimately end up doing this method. This gives you a tremendous amount of control, a tremendous amount of standardization, and it's generally the thing that I recommend. But it's not always an option because you don't always have the support of a database professional. So another publicly available option is to get one from a data feed provider like Azure Data Market, and I won't go deep into that, but I'll show you how you can find out more about that option. A third option, which is sort of new and emerging on the scene, is to use this new tool from Microsoft called Power Query. And that is something that we will touch upon, at least briefly, in the bonus material. But it's not going to be making an appearance in this particular lesson. And then the last one, which I think is going to be very common for a lot of people, is to use Excel itself to generate and produce your calendar table, which then, of course, requires some sort of linkage mechanism to get it into Power Pivot. And that's really the one that I'm going to be showing in this section, because if you have option 1, then that's not going to require much of a tutorial. It's called go talk to your database buddy and get them to produce a calendar table that meets your specifications, or maybe you are the database pro. 2 and 3 are sort of exercises left for the reader, but I want to make sure that everybody's got at least some sort of fallback option to. And I'm not just going to talk about it. I'm not just going to show you how to do it. I'm actually going to give you a reasonable jump start on making calendar tables in the form of a workbook that will be available to you as a download. And I should mention that I don't expect this workbook to be exclusive to this class. I think it's something, I thought about this first with regards to sharing it on the blog. But you will have first crack at it here in this course. Okay, so the columns in this workbook are kind of the real vanilla base lowest common denominator kind of columns that you'd want in a calendar table. And I apologize, this is very much US centric. So apologies to those of you who use different sort of different locales and things like that. But I think even here, this would be a good starting point for you to customize for your own needs. So it just uses the regular old Excel functions, and they're all referencing column A, which is what contains dates. And some of it gets a little bit more involved than others, perhaps, but really pretty straightforward. And every one of these calculated columns is something that you could write in Power Pivot. I mean, you could just import a single column of dates into Power Pivot, and then write a whole bunch of calculated columns in Power Pivot to produce all of these things. And the reason why, at least in every case except for the text function, it'd be exactly the same formula in Power Pivot as well. In Power Pivot, the text function is called format. So file that away for future use. But there's a big advantage to doing it here in Excel as opposed to doing it in Power Pivot, which is that I have the opportunity now to reuse this logic across workbooks. So if I put all of the calculated columns into Power Pivot, then those calculated columns, those formulas, are going to be stuck in that workbook. And if I need to go create a second workbook later on that might be a completely different data analysis problem or domain, I mean, I still need a calendar table, and having to rewrite all of those calculated columns from scratch isn't going to be a lot of fun. So if we do it here in Excel and then import it into Power Pivot, we have the opportunity to get some standardization, to get some reuse. And reuse, and therefore saving time, is one of the big themes, one of the big reasons to be using Power Pivot in the first place. So I highly recommend using an external source as much as possible for your calculated columns in your calendar table. So the name of this workbook is Calendar Generator. There are no macros in it, and it's an XLSX file. But the one thing that's interesting about this is that even the date column itself is a formula. And the reason that I've done this is, well, first of all, everyone's got different calendar needs. So, many of you won't care about 2010, and some of you will want to go back quite a bit further than 2010 into history. And I certainly can't build a fixed column of dates that would help everybody. But the other reason is that I think it makes a lot of sense for your calendar to be, in a sense, something that you can quickly parameterize. So here on the Inputs tab of this workbook, it's very straightforward. I haven't put a lot of time into this. There are 4 inputs that you can enter. So one of them is the start date of your calendar. So if you want your calendar to start on the 1st of 2012, you just enter that different date here. Go back to the output sheet, and you'll see that now January 1st, 2012 is the first date in the output. And then the second input is whether you want a fixed end date or whether you want it to be variable. And so if I set this to fixed, then this date here, this 12/31/2013, that is going to be the last date appearing in my calendar table output tab. But if I set this to be variable, then this comes into play. This today function comes into play. And so every time I open this workbook, this today value is going to become the read off the system clock and become today's date. So now you actually know what day I was recording this now, don't you? Remember, I went back to put this lesson into the middle of things I'd already done. I was feeling guilty about not giving you the calendar table answer. So, and then sometimes you want your calendar to lag behind today. And so like if you want it to be 2 days behind us, sort of your end date, then you can do this. You can also set this to 0, and it becomes, so the end date over here becomes the same as today. And you could also, if you wanted, you could set it to be 2 weeks in the future. Set this to 14, and now we're 2 weeks into the future. And having a calendar that is what I call trimmed to to the just sort of the relevant date range that you've got makes a difference, especially on slicers. Like if you want to put a date values and month names and years and things like that on slicers, you end up with that whole the behavior that you get on rows of a pivot table, which is don't show me values that are blanks. You don't get that on slicers, so you end up having a lot more slicer tiles than you need, and that's just one consequence of it. There are other things we've seen in terms of when you're writing measures that count days in the calendar. Sometimes it's also beneficial to have a trimmed calendar. So this will do all of that. And what happens is that this formula that I've written over here, it's filled down all the way like close to 14,000 rows. So a couple of decades here for sure. This column just returns the sort of like a blank value if we're outside the selected date range that's been specified on our input tab. Okay, so what do we do with this? And because I want this to sort of be portable and to use it across lots of different cases, and also because I've got these blanks in here, don't worry about the error values. I'll show you why those aren't going to matter. For a number of reasons, I choose not to use the Power Pivot create link table option, which is the add to data model in 2013. Instead, what I do is when this looks the way I want, I just go and save this workbook as a CSV file. So if I just select CSV from the list here, and we'll call it my calendar, and it says, okay, it's gonna drop your extra sheets. It's gonna throw about 5 prompts at us here, yes. And then I'm gonna close this, and I don't want to save again, so don't save. And now I'm going to create a new a new workbook from scratch to import that calendar table into, and open up the Power Pivot window and import from text. Set this to CSV again, so my calendar. And the really important thing to do here is to go to the date column and scroll to the bottom and deselect blanks. And that's going to take care of getting rid of all of those rows from the bottom of our CSV file that were the blank formulas, the blank dates, and therefore all of the error values that went with them. So this is going to be just the valid dates from the specified range back in my calendar generator. And we wouldn't have that option if we were doing this as a linked table. All right, so 628 rows came in, and it goes from, if I sort this from oldest to newest, it goes from the 1st of January 2012 all the way down to September 19th of 2013, which is what my calendar generator was set to produce. And if I want to update this tomorrow or next week, I just go back and I reopen my calendar generator. And if I have this set to variable and it's a new day, this value will have updated. It will have used my offset. I didn't save the 14 here, which is or the start date. I would do that. I'd save the calendar generator with my specified start date and all my selections here. But I'd open it up, and today would update. I get a new end date. My output tab would update because the today function will be reevaluated when I open the file. And so all I have to do is open this file. If I've saved my inputs on the input sheet, I just open this file and then just do save as CSV again. It's actually the kind of thing that if you're savvy with macros, you might even put like a save as CSV macro button on your quick access toolbar. No matter what you do, though, you want to make sure you save it as the same file name that you imported into Power Pivot. So mycalendar.csv in this case, because you want to be able to flip back after you saved it into the Power Pivot window of your workbook and then do the refresh here. So it'll pull in the latest from the CSV. So this is still a two-step process, but I'm trying to make that as sort of minimal as possible. You're not having to fill down any formulas or anything like that, which is what I was trying to avoid. And I did use a completely blank workbook to import into here, but don't be fooled. In real life, of course, I'd be importing this calendar into a workbook with other sheet tabs, with other Power Pivot tables, data tables, lookup tables, etc. But this will be a pretty, again, it's just a starting point. Feel free to modify this for your own needs, add a whole bunch more columns, make suggestions to me in ways that I could improve it for everybody. Fair game, all of that. But I wanted to give you a way to at least a fallback for producing your own calendar tables and doing so in sort of a robust, low hassle, and reusable manner. Moving on, let's do a fiscal year-to-date version of this measure. And right now I have the regular year-to-date sales measure in the editor, and I'm going to backspace a couple times here, and I press comma. Here's that year-end date input that we neglected. We didn't do anything with it this last time. So this is how we do something, how we adjust the end date of our calendar and do things like a fiscal year. So I'm going to I don't want to change this formula because this is my existing year-to-date sales, but I'm going to copy this right here and then cancel out. We're going to write a new measure, and we'll name it fiscal year-to-date sales. Okay, and now I pasted, and we can do year-end date. Now, the way that they want you to put the year-end date in here is a little weird. They want you to input it as if it was a text value, so double quotes, and then remember it's the year-end date, not the year start. So we want it to be 6/30/2002. If we want, assuming a fiscal year that starts on July 1st, it ends on June 30th. And like I said, it's a little strange that we're inputting a year because this measure is going to end up working for all years. So even 6/30/2001 should work here. But that's what we're going to do. 6/30/2002. That's our optional year end date. And then we close it out. Set it to a currency like always. And let's give it a little conditional formatting just to see the difference versus the others. Okay, so our fiscal year, because July 2001 is the beginning of that fiscal year, this one stair steps up all the way into, it crosses the boundary between 2001 and 2002. It doesn't reset until July of the following year. And so if we scroll down, you'll see that they're just a nice sort of out of phase by 6 months pattern, which is exactly what you would expect for something like this. And then down at the bottom of the pivot table, we see that the grand total is a very small number, and that's because it just so happens that our fiscal year rolls over between these two cells. That's when the new year starts, and we don't have very much data after that. So we don't have any sales transactions that happen after that, and so coincidentally, we end up with a very small number here. But that's exactly the right number, and it's exactly calculated the same way as regular year-to-date, except that it rewinds to the first day in this fiscal year rather than the first day in the calendar year. So this would rewind to the first day in July, and that's why we get this for the grand total. We also get it here and here, okay? Okay, fiscal year-to-date. That was easy. Let's take total sales off to give us a little bit more room in the pivot. And now let's do a quarter-to-date version, just to show you that quarter-to-date and month-to-date are basically the same thing. So another another measure, quarter to date sales, and equals calculate. Total sales, dates, QTD, and again the calendar date column. Okay, and currency, and this is going to be the calendar quarter to date, not the fiscal quarter to date. So, all right, and then again, let's see what its stair step looks like. Running out of colors to use here in the default drop down, but yeah, we get a 3-step stair step every time. Okay. Again, very much consistent with what we would expect. So now we've got quarter to date. That's pretty cool. We could also do month to date. It's the same sort of thing. You know, these things, quarter to date, month to date, operate the same way. They find the latest date in your filter context, and then they rewind to the first day in that quarter or the first day in that month. So again, just wash, rinse, repeat with the same concept. Nothing particularly new there. All right, now it's time for one of my favorite things, which is the dreaded trick question. Do you remember back when we were using dates between, and we put the calendar is weekend field on our pivot? We're going to put it on as a slicer this time. And dates between completely overrode that weekday weekend setting, and so it didn't matter. No matter what we did with the is weekend field, it didn't matter. We got the same result whether we had selected one or the other or left it unfiltered. Okay, so what do you think is going to happen with DatesYTD and DatesQTD and all of those functions? What do you think is going to happen when I manipulate or select something on the is weekend slicer? Is it going to make an impact or is it not? Okay, and I have told you everything you need to know in order to answer that question, but even I had to spend a little time to figure this out myself. So don't feel like you have to just know the answer. So let's go ahead and click on weekday, and let's watch these numbers and see if any of them change. So it looked like some of them changed, but not all of them, which is very, very strange. Let's kind of go back to all of them. You see that like this number here, 1.147, that is not changing. It's still 1.147. But the number right below it, 1791, when I select weekday, that is changing. And we're sort of seeing the same thing. There's in each one of these columns, there's a couple of numbers that are changing, but not all of them are changing. And then if I do weekend, it seems like a larger number of them are changing when I select weekend. There's maybe a couple of them that stay the same, but most of them are changing when I select weekend. So let's focus on this February 2002 number, because when I select weekday, let's focus on the March 2002 number, because when I select weekday, the March 2002 number changes. Let's step through this really quick and see why that selection is making a difference on that cell, but not on many of the other cells. Okay, we go to the calendar, and first let's step through it with the slicer cleared. Okay, so the filter context for this cell is just March 2002. That's the only coordinate in the filter context. So in terms of DatesYTD, it starts out with March 2002 as the filter context, and then it picks the last date in that range, which is March 31st, and then rewinds to the beginning of the year, to January 1st. Okay, so that's what happens to with DatesYTD when I don't have any selection on that slicer. However, when I select weekday, now we have a March 2002 and a weekday We have 2 coordinates. And if we look at what that looks like in terms of initial filter context, we get something different, don't we? The Saturdays and Sundays are excluded. And so our original end date of the 31st is no longer part of the initial filter context. Our initial filter context ends on the 29th, and it rewinds from there. And just like dates between, it does, once it has its end date, once it knows its end date, DatesYTD forgets everything else about the calendar in terms of filter context and just rewinds. So it ends up including the weekends, but just not the 30th and the 31st of March, because those are past the end date. So I don't think that's gonna come up very often, but it's just a really great way to drive home just how mechanical these functions can be. And if you, again, stepping through them and understanding how they operate is the key to debugging them when something doesn't quite look right. Anyway, I hope you enjoyed that trick question. All right, one more thing in this section. Another thing that I get asked a lot is, okay, so this is great. I got this year-to-date sales measure, and it resets at the beginning of every year. But what I want is a lifetime-to-date sales measure, one that just keeps stair-stepping up. It doesn't reset as it crosses the boundaries of each year. And this is a great time for us to bring dates between back into the fold. So let's use dates between again, and let's get a couple of these others, the FYTD and QTD. Let's get those off of the pivot and write a new measure. All right, we're going to call this the lifetime to date sales. And again, it's going to be a calculate of total sales. Oops. Total sales. And then we're going to do a dates between. So dates between, again, the calendar date column. And well, what are we going to specify for the start date? Okay. Let's come back to that. Okay. Let's do the let's fill in the end date first. Okay. So the end date is the last date of calendar date. And if you think about this for a second, this is exactly how the DatesYTD function operates. It looks at the existing filter context, and it takes the last date that it can find that corresponds to that filter context. So this is going to be detecting that endpoint. It's going to have the exact same impact as, at least in terms of endpoint detection, as DatesYTD does. But it's that start date that we want to be different. We want that start date to go back to like the beginning of time, okay? And there are a number of ways that we can do that. We could enter a start date manually here that goes way back. We could also do sort of a first date in combination with an all. Let's start out with hard coding a date. So we know that our calendar table starts with, let's find the first date in our calendar table, okay? So it starts on July 1st, 2001. That's sort of the first date in history as far as we're concerned. So let's try entering that here, 7/1/2001. Okay, and then we need to close the calculate. It's closing the dates between, and then we close the calculate. And I want to check this formula before I commit to it here. All right, so it says there's no problems. Let's hope that that's the truth. And it is. Let's format that guy and make sure that it's looking correct. So, and now let's apply a conditional format to this one. And we see that that stair step does continue all the way to the very end. And so there is one way to do a lifetime to date, is to just feed it a hardwired date from way back when. And that tends to be okay, because one thing that doesn't tend to change over time is the past. Hardwiring an end date is a lot more dangerous because, well, every day goes by, you get more data. But in terms of looking backwards, that's a fine way to do lifetime to date. You've got this pivot now, and you're incredibly jazzed about it. So you go and you show it to one of your colleagues, and you say, "Hey, what do you think? Isn't this great?" And of course, your colleague, she says, "Well, that is great, but all these numbers are bike sales primarily, and I don't manage the bike sales channel. I'm all about the clothing and accessories. So it's kind of a novelty. I don't think I could really use this." And normally if you'd put a tremendous amount of effort into building an Excel report like this, and you show it to someone and they told you something like that, you'd be crestfallen, like, all that work wasted, and now I got to go do a whole bunch of other work just to give them something useful. Now with Power Pivot though, you are not going to feel that way. I know this is something that I just keep beating like a dead horse, but I want to make sure 100% that at all times you're keeping this in mind. It's not going to take you long to produce exactly what your colleague asked for. And let's just start off by making a copy. I'm going to make a copy of this sheet. And so now I'm on the copy sheet, and I don't need is weekend anymore. And I talked to her. She doesn't care about anything like lifetime to date. Oh, I dragged the wrong one off. Okay, so she really likes fiscal year to date. So that we're going to keep that one. Like she said, she cares about the accessories and clothing categories. I paused for a moment because I was a little confused why bikes is grayed out here on the category slicer. If I click it, I do get data. So I think that's actually just a temporary glitch. If I click components, there is no data for components. But there should be data for, this should be enabled right now. So anyway, I can select accessories and clothing, but I can also put subcategory on columns and see what that looks like. And I can select clothing and see how the different regions, not different regions, but the different subcategories, how they perform. I can also turn off the grand totals off for rows and columns. It gives me a little bit more real estate, and do this as well. So now I have, with just those few clicks, I've given her what she was asking for. She can now look at clothing year-to-date, fiscal year-to-date sales actually, and see how things have been performing. Now, why is it that my fiscal year-to-date sales is constantly stair-stepping up? Well, it's not actually. It is just going 12 months, and then it resets down here at the bottom. So no worries there. But I can also zoom in to just particular years and bounce around. But this is, if I use the regular year-to-date, then I will get a different, definitely a different stair step here, which is probably more what we were expecting to see, which has the reset right here in the middle. Okay, but in order to give her what she wanted, provide the right information to my colleague, the formulas, the logic, everything that I built can be quickly repurposed with just a few clicks, a few drags in the field list. And now I'm looking at something that actually is useful to her, and I didn't have to reinvent the wheel. Big improvement over the old days. Let's keep moving. Next up, let's look at very common need, which is to compare how we're doing right now with how we were doing a year before at the same time. And to do that, we're gonna, as always, we're gonna write a measure, and we're gonna call it last year sales, okay? And it's gonna be a calculate of total sales, just like we've been doing a bunch of. But this time, we're gonna introduce a new function. It's the date add function. So date add is a pure shifting function. So it takes your existing filter context from the calendar and it shifts it backwards or forwards and by a particular amount. And just like almost all, or maybe all, of the time intelligence functions, it wants calendar, wants your date column first. Number of intervals. Well, we want to go back one. We want to go find one back, and it asks what kind of interval. And this is another one of those that's kind of weird the way you have to type it. You just type year without quotes, and it's not a function. So you're gonna shift back 1 year. You're gonna take total sales and go back 1 year with it. So semantically, that seems pretty straightforward, doesn't it? And let's take a look at what we get. So we've got quarter on here right now. The Q3 2001 is our first quarter on our calendar, and we've got Q3 of 2002. And hey, look, they both match. So this matches the same value from a year ago, and that continues all the way down. And so we could also write a percent growth versus last year measure. So let's do that really quickly. New measure, percent growth versus last year. I will just abbreviate that. And well, what is it? It's total sales minus last year's sales, and we'll divide all of that by last year's sales. Now, what we're going to hit that pound num problem. So let's not do it this way. Let's use that safe divide function again that I'm so fond of these days. So the numerator is what we had there, and then the denominator, I don't know why the oh, there we go. The denominator is last year's sales. Oops. Last year's sales. Okay, and then that's going to be a percentage. Okay. There's our percent growth measure. So we weren't doing so well for a little while in terms of growing, and then we got quite a bit aggressive, and then this is where our data runs out. So it's not surprising that number is negative. One thing you might notice is that all of these numbers match their last year equivalent, but this number, Q3 2004, is at 1.7 million, and Q3 2003 is at 2.7 million. And why is that? Well, we need to examine how date add actually operates, and it's going to be very, very familiar. It's going to be reminiscent of the other things that we've been looking at. And again, we're gonna go to the calendar. Let's start out by stepping through how this particular cell here was calculated. So Q4 of 2003, and let's go to our calendar. Q4 of 2003 corresponds to October through December of 2003. So that's our initial pivot table provided filter context. And the way date add works is that it finds the first and the last date, DatesYTD, we've seen it, how it grabs the last date in the currently selected filter context and then projects backwards. So DateAdd does find that last date similarly, but also finds the first date in the currently selected range. And then it projects both of those dates, the start and the end. It projects both of those. It doesn't rewind and include the dates in between, but it just hops back 1 year with both of those dates, and you end up with a 3-month period. So it's the same sort of length period, 3-month period selected from 1 year back, and then that is the filter context that is fed into the math engine, and you end up with, you get the same answer as you would for the regular sales measure over that same 3-month quarter. Okay, so why do we get a mismatch here? Well, the reason for that is that our calendar table trails off before the end of Q3 2004, and we can see that because our greatest date, our most recent date, is the end of August, and so that means the entire month of September is not there. So if we look at our calendar, we will see that, well, we have the missing August here, but we can certainly imagine it being there. So we have July and August that get selected by the initial filter context. So we have a 2-month period, and then that projects back to July and August of 2003, and we get that number. So we end up being, essentially like 1/3 less, kind of on average than what we would expect. And that's why in that one particular instance, we get a mismatched number. Again, very mechanical. First and last date in the filter context, move them both back by 1 year. And because of that, we find the first and last date and then move back. That means it works with basically any chunk size of time of the calendar. So for instance, right now we're looking at quarters, but we can go into the field list and grab month year, and we can see that 473 matches 473, 506 matches 506, that kind of thing. And then if I really want to, I can take both of those off of there, and I can just put date on the pivot. And of course, we're getting blanks here because there isn't any data from a year before this particular date. But if I control down arrow, I'll hit the first time that we get something for last year's sales is July 1st, 2002, and it's 14,477. And now if I zip back up to the top, you'll see 14,477. Now the one thing that DateAdd is not particularly good at is projecting back weeks. So I'll explain that in the next part. At this point, we've done lots of to-date style calculations like year-to-date, lifetime-to-date, quarter-to-date, even fiscal year-to-date. And we've also done things with the DateAdd function, like going back a year, last year sales, and percent growth versus last year. And the next thing I'd like us to cover is something, the concept of a moving average. Moving averages are useful because they smooth out the random noise in our data. In another workbook, just to show you an example of this, it's not the same data set. You see here that the red line indicates our actual units sold on a month-by-month basis. And the green line is the moving average version. It's actually a 3-month moving average version of that same measurement, that same units sold. And it takes a lot of the, as I said, sort of the edge off of the data. And as human beings, we have a tendency to overreact to random fluctuations. There's even a book called Fooled by Randomness about this phenomenon. And you see here this drop, this 1 month drop is quite significant in terms of a 1 month drop. but you'll notice that the 3-month average doesn't even blink. The 3-month moving average does not blink at that moment. And so the 3-month average helps us to not overreact to our drop or even our increases. Whereas here we would see that the 3-month moving average validates that we actually did have something big going on in this particular case. So it makes for a smoother line. It allows us to not overreact to bad news or overreact to good news. And so now let's just see how we write that as a measure in Power Pivot. Okay, back to our original workbook. And I have a pivot table waiting for us here that has total sales displayed on a month-by-month basis. And I have it filtered down to 2002 with the slicer here, just so we can have a smaller lens here to look at. And if we wanted to, so this is our total sales amount for July 2002. And if we wanted to do a 3-month moving average version of this, so for instance, these 3 months, the average of them, which we see down here to be 616,895, that's the number we want to appear here. We want that 616 number to be here in our new measure. So let's sort of incrementally work our way up to that, and we'll start off with a 3-month sum. So 3-month moving sum will be our first measure, and we could do so. Obviously, this is going to be a calculate, and it's going to start with total sales, and we could do this. The first instinct that we have would be to do this as a dates between. So we would find the last date in July, for instance, and then roll back to the first date in May, and then from there we would sum up our total. So we could do that, but there's another function which is a bit more suited. It's a little bit less clumsy, and it's called the dates in period function. As always, with all these time intelligence functions, it takes the calendar date column, and then it wants a start date. And so what dates in period does really is it blends together the date add function and the dates between function. And so we don't have to provide two separate start and end dates and calculate what they are. So the start date, in this case, we're going to go backwards in time. So we're going to catch the last date in our calendar date table. Okay. And that's going to be, for instance, the last date in July for that cell that I was just looking at. And now we're going to go just like with the date add function. We're going to go with -3 month, -3 comma month, and then we will close our dates in period function. I'll resize this a bit so we can see what we're doing. Close the dates in period function, and then close the calculate function. Set this to be a currency, and say OK. Right. So this is, remember, the 3-month moving sum. So let's see if it's accurate. These three together add to be 1,850,685, which is exactly what we get here. And so let's take a look at the calendar and see what's actually going on. So if we minimize everything here, and we were focusing on the selected cell was July 2002. So last date of the calendar date grabs July 31st, and then from there it rewinds three months. So we catch all of this month, all of that of June, and all of May. Now, some of you might be wondering, Rob, you said that dates in period operates like a combination of dates between and date add. And yet, when we just looked at this example, you told us that dates in period going back 3 months from July 31st stopped at May 1st. It didn't go back to the same month end date in April. And date add, if you use date add to go back 3 months, you would get April 30th. But with dates in period, we only got back to May 1st. Is that right? Is that what we really saw? And the answer to that is yes, that is exactly what we saw. And I can show you back in the workbook, I have another pivot table that I've added here just to show the difference here. And so I have 4 measures on this pivot table, and they're all measures that return dates, only dates. Columns F and H use dates in period. Columns G and I use date add. And they're intended to be basically the same calculation, just implemented with those 2 different functions, just to show off the difference. And so first date via dates in period basically says go back 3 months from where we currently are and tell me what the first date is that you have in the resulting date range. And so if we go back from the first day in July in 2002, we end up on the 2nd of April, not the 1st of April. Whereas if we do the same thing with -3 and date add, so again, take the first date in whatever range we end up with, going back 3 months, we get April 1st. So, and the same is true when we go the other direction as well. So when we go forward in time 3 months using last date, using dates in period, just to show you here, we use the last date function instead of the first date function because we want to see the endpoints. So we go forward 3 months and we get September 30th, but when we go forward 3 months with date add, we get October 1st. So the difference here can be best explained by dates in period. When you go back 3 months or forward 3 months, it results in a period of time that is 3 months in length. So there's 3 months worth of days in that period, whereas date add jumps ahead 3 months, resulting in, if you grabbed every date in that range, you would get a month plus 1 days, because the original day would put it over the top. It's kind of like saying if you add 1 day with date add, you get tomorrow, but if you included both, that would be a 2-day window. So it's sort of like a difference between the length in a period versus a jump, a navigation in time. And dates in period speaks when you say 3 months or whatever, it's doing a resulting period that is that long, not a period that is starting from a particular date and then jumping forward that many months. Now that might be a little bit of a detail, but it turns out that's exactly what we want. We want to have a period that is 3 months in length when we're trying to do a 3-month moving average. So this works out completely in our favor, and it reflects some serious thought behind the scenes at Microsoft. With that explained, now we can go back to our previous pivot table where we were developing our measure, and we have a 3-month moving sum that is accurate. But we don't want a 3-month moving sum, we want a 3-month moving average. And the easiest way, not necessarily the most correct way, but the easiest way to get a 3-month moving average once we have the moving sum version is to create a version of that measure, a new measure, 3-month moving average that is the original measure we have, so equals the 3-month moving sum divided by 3, because we know it's 3 months. And so let's just take a look at what this looks like. And this is going to be accurate for the data that we've got at the moment. So for instance, if I select these three, we will see that the average is 1.858644. No, sorry, that's the sum. The average is 619548, which is what we've got here. Now, in many cases, that divide by the number of months, divide by 3, might be completely adequate and a fine solution. But I did hint that it does have some limitations. So, for instance, if I clear the year slicer here, and we go back to the beginning of our time frame, we'll see that for July 2001, we had total sales of 473,000, and our moving average is reporting 157,000. And so what we're seeing, of course, is that even when we have no previous months to include in the moving sum, the average is pretending like there are 3 months to divide by. So we're unfairly depressing our moving average for these first 2 months. Even the second month is a little bit low relative to subsequent months. So maybe you don't care. Maybe those sort of earliest months at the front end of your history, the back end of your history, maybe those don't bother you. But if they do, and you need to get these correct, and really the only way to make this one correct is to return the same value as the total sales in that particular case. And to do that, I need to fix the denominator of my moving average measure. Right now, I have that 3 hard-coded in there, and we need to do better than that. And we could do some sort of crazy if type of detection there, but really we need to apply. I think one of the most elegant ways to do this is to apply the same logic to this denominator that we do to the numerator. So this 3-month moving sum is being calculated using the dates in period function, and we can do the same thing for the denominator, also using dates in period. In fact, I can go and take the 3-month moving sum measure formula that's and do the pre-highlight, right-click, copy that formula, and then go back into the 3-month moving average, measure, and I can replace that 3 with the pasted formula that I just got from the moving sum. And I can fix a little bit of the formatting here. We can zoom in a little bit. And so the only thing I need to change here is that I don't want to calculate total sales up here. The thing I want to calculate here is the number of months. And we can do that with a distinct count. The autocomplete doesn't seem to want to work right now. So distinct count of calendar. Now it's working. Calendar. We can do month year. And I think that'll work. Month year is a unique, it's unique for each month of each year. So we've got a denominator here that most of the time is going to return 3 because it's going back over a 3-month period. But it is not going to fall, when it falls off the front end of the calendar, it's going to return fewer than 3. So let's try that out. Oh, I missed a parenthesis somewhere. Calculate distinct count. Yep. So for the first month in our calendar, we get exactly the same value as the first month. And of course, that could be said to be the 1-month moving average that corresponds to that. And then for the second month, well, this doesn't match 506, but it does match the average of those first 2 numbers. So we get we get a moving sum moving average for the first 2 months. And then from that point forward, we get the 3-month moving average behavior. So that has solved our problem in terms of the edges of our calendar. The only thing left, of course, is to see if we get that smoothing effect in our chart that we desired from this whole thing. And 3-month moving sum is on a different scale as these two. 3-month moving average is on the same basic scale as our total sales measure, whereas 3-month moving sum is going to be roughly triple our total sales scale. So let's get 3-month moving sum off of here, and let's go ahead and add in a pivot chart just right over the top for now, a line chart, and we can do 2002 and 2003 just to get sort of the middle range of our data. And as we expand this chart a little bit, we'll see that our total sales measure is more jagged than our 3-month moving average. They do parallel each other very nicely, but it takes out some of that random noise that we will just naturally experience on a month-to-month basis. And I could spend some time making this chart prettier. I can take off some of these things that make that are cluttering the axes and things like that. But just wanted to verify that we're getting the desired smoothing effect while not diverging from our underlying trend. Next up is what I call the inventory family of time intelligence functions. And there's 6 of them, and they follow a pattern. It's closing balance, and then either a month, quarter, or year. And then the other 3 are opening balance, and again, month, quarter, and year. And as always, these are best explained in the context of an example. So let's switch over to Excel and look at it there. I called those functions the inventory functions, so it shouldn't be surprising that those functions are best demonstrated using something that at least resembles inventory data. And to do that, I have imported a new table into my model. It's called parts inventory. And you'll notice that I have it positioned as a data table because it is, and it's only linked to a single lookup table, which is calendar. So that's its place in the model. And if I go here and let's go look at the parts inventory table, it's very simple. It's just 3 columns. So there's a date, and then a type of part, and then the inventory that we recorded on that date. And again, this is just manufactured, made up data. So we shouldn't expect anything terribly meaningful from the trends in the data itself. But structurally speaking, this data fits the idea of inventory. And rather than invent inventory for every single product in our catalog, I went ahead and just pretended that these were inventory just for raw materials for making bicycles. So chains, sprockets, and steel tubing. So there's only 3 different kinds of parts in here, and for each part there is a single value on a single date, and every day from our calendar is represented in here. So very straightforward, and this came from a CSV file that will be made available to you as part of the data for this module. And you see that there was a column that I did not import. I didn't import the raw inventory raw column because that was just something that I used to help manufacture the data in the first place. So it's really just these 3 that I brought in that are important. So this is sort of a tour of what the data that's the test bed for showing this stuff off. But the real action, of course, takes place back in Excel, where I have this simple pivot that has part from that inventory table. And normally that's the kind of thing that we would expect to see coming from a lookup table, but I didn't bother this time. It's just 3 values, and it's not terribly useful to create a separate table for that purpose this time. So that's just the part column from the parts inventory table. And then I have quarter, year, and date from the calendar table, and I have those collapsed at the moment. And then I have this quantity in stock measure that I wrote, and let's take a look at the formula for that. So when I started to write the base measure for inventory, and it's just in this case it's the min of the inventory column, I was I had a choice to make that was a little bit odd for my aggregation function. What is the inventory? What's a good aggregation function that tells me something meaningful about the inventory? I certainly don't want the sum of the inventory, because unlike in sales tables, in a sales table, every row is meant to be added up, because if you make 3 transactions, you sell something 3 times, well, that all piles up. But in this case, we're just taking sort of measurements of a level of something, how much we have in stock. So from the July 6th through 8th, it's not like adding 48, 39, and 39 tells us anything. It's not like that at all. An inventory is not cumulative in that regard. So what is a good aggregation function to use in such a measure? I mean, so I defaulted to min, which would, in a particular time period, report to me the lowest that my inventory got. And I suppose that is in itself a useful metric. And I guess max would also be a useful metric, in that it would tell me the highest my inventory got. And but certainly I wouldn't want to sum this, and I guess average would be relevant in some cases, but it's not nearly as clear which aggregation function to use for something like inventory as compared to what function you should use for sales, which is almost always sum, at least in the simplest measures. So, but I went ahead and I made this this minimum measure because I needed some starting point, and so that's what I've got. And as I slice by the different part types, you'll see that I get different results. So at some point during Q1 2002, we actually bottomed out at 0 chains in stock, and the same thing again in the second quarter of 2002. But very often, the thing that you want to know is you want to know what your inventory was at the beginning or the end of a particular time period. And so that's what these 6 inventory functions are good for. So let's take a look. I've already written them. Let's take a look at the closing balance quarter version of this. So these functions take more than 2 inputs. The others are optional inputs. But the 2 that are really important, and it's kind of interesting that for once these time intelligence functions have the date. That dates function, that dates input, is not first. Is not first in the list. But we have quantity in stock. So that's my original measure. This is the quantity in stock measure. And so all this is really saying is, based on the calendar date, which is what we sort of feed to all of our time intelligence functions, go and find the value of this measure on the last date in the current quarter. Okay? So if I say cancel here, and I put this closing balance measure on the pivot table, so I see that I have 65 here for a chain in Q3 2001. So if I expand this and then scroll down, we'll see that 65 is the value of our base quantity in stock measure on the last day, the last date in that quarter. And so all the dates, so for this other measure, the closing balance measure, every single date in that quarter returns that same 65 value. That is the value of this measure, quantity in stock, on the last day in that quarter. Okay? And so the only one that confused me, the year and month versions of this function, the closing balance functions, they work very much the same, although the closing balance year function does allow you to set your year-end date to account for fiscal calendars and things like that. But the thing that threw me off, actually, when I first started using these functions was not the closing balance function. It was actually the opening balance function. So I have a closing balance, and then if I put the opening balance version on here, which is the same exact formula, just using the opening balance version of the function instead of the closing balance, you'll see that it actually matches the closing balance from the prior quarter. So 65 and 65, 39 and 39. And I actually originally expected opening balance quarter to report the first day of that quarter. So the first day of that quarter is 68, and this is reporting 65. So why is that? It's actually because this one, the last day of the previous quarter was 65, and so opening balance actually looks back to the prior time period, and it's like the same as using the closing balance function against the prior period, as opposed to, it's not the first day in this quarter that it fetches, it's the last day in the prior quarter that it fetches. So the same thing happens for month, and the same thing happens for year. They're really just wash, rinse, repeat with these functions, but they're good functions to know for certain. And if you're dealing with inventory, there's really not a whole lot of alternative here. But this is one opportunity to show you that, another opportunity anyway, that many of these time intelligence functions are just kind of wrappers to each other. So just repackaging. So there's another way to write the closing balance formula, and I've got it here, which is the calculate approach using the end of quarter time intelligence function. So all this does, it's almost like dates in period, that completely resets your time context, your calendar filter context. But instead of setting it to a range of dates, it sets it to a single date. Whoops. It sets it to a single date, and that's the last date in the current quarter. And the opening balance, if we wanted to do the opening balance measure with this method, it would be a little bit trickier because we'd have to go back a quarter and then do end of quarter of that previous quarter. But you get the idea that a lot of these time intelligence functions are mix and match. You can use them. You can get to the same result many different ways, and some of the functions are just more convenient ways to do the same thing. And furthermore, even this end of quarter function is it's just a member of a family. So you see here that I've got end of month and end of year, as you would expect. And then I've also got the start version, start of month, start of quarter, start of year. So there's really 6 functions that parallel these closing and opening balance functions as well. Okay, first non-blank and last non-blank. These are actually primarily time intelligence functions, believe it or not. They did appear earlier in the class, very briefly. I used them to kind of fetch a text value. And I think I may have even misrepresented what one of the 2 inputs to these functions actually does. And I tend to do that. I get confused sometimes when I use these functions for purposes other than their time intelligence purpose. It's a little strange sometimes the way that they behave. But let's cover them from their time intelligence usage perspective, and then also clarify the way in which I used them previously. Let's set up a problem that functions like last non-blank and first non-blank are particularly designed to solve. So here in this pivot table, I have selected a product on slicers, this classic vest, the small size classic vest, for which we really don't have what we would call robust sales. It's not a big selling product. And I did that because the question I want to ask here is when was the last time that we sold this product? Either all time or even in a particular month, like what we have here, what was the last date on which we sold this product? So I'm going to add a measure to the calendar table. And we're going to call it last sales date. And we're going to use the last non-blank function. And the first input to last non-blank is the name of a column, and that's the column that you should think of as being sort of like the sort order column, or the column that is not sort order, but a column that has a sequence to it. So date is the primary example of a column that has an order to it, and this is why the last non-blank and first non-blank functions are primarily used or thought of as time intelligence functions. And that second input is the thing that gets evaluated to see if it returns blanks or not. Okay, so for every value in the calendar date column, we're going to evaluate an expression, and in this case, we will do just total sales. And what's going to happen is it's going to return to us the last value of calendar date for which the total sales measure does not return a blank value. Okay? And this is going to return a date, so let's go ahead and format it as a date. Okay? And so we'll see that some months, like for example in December 2003, the last time that we sold that product was on the last day of the month. But in other months, such as August 2003, we didn't make it all the way to the end of the month. So we didn't have sales on the last couple of days of the month, at least not of this product. Now, if I switch to a different product, one that maybe sold more total volume over time, I'm going to get obviously different sales dates. But I started off with this classic vest small because it's one that has some of the more interesting end of month dates. I'm sorry, not end of month dates, but last sales dates. And it shouldn't be any surprise by now that the grand total result for this particular measure is equal to the latest result from each individual month, because this will be evaluated in a completely unfiltered filter context, and the last sale of all time then is the one that it's going to return. And similarly, of course, we can write another measure that is the first sales date, and this one will be, instead of last non-blank, it will be first. I don't know why the autocomplete decided to stop working. First non-blank. First non-blank, and it's the same exact input. So calendar date and the total sales measure. We'll again set it to date. And we could also, at this point, so it might make sense to put first sales date first here. We could even write another measure that was the difference. We could subtract these two from each other and get a whole number of days in between sort of the first date and the last date. So this is going to be useful. Sometimes you actually care about the things like this, the first sales date, the last sales date, as actual values to put in your reports or in your dashboards. And other times, you want to use this first non-blank and last non-blank function as sort of an intermediate step to get to something else. So for an example of that, sort of using these as an intermediate step, let's skip ahead here to this new measure I've got, which I've called fraction of year between sales. So basically what this means is that between the first sales date and the last sales date in January 2004, that time frame represents 7.5% of the year. And again, this might be useful in some cases. This measure itself is more just something I wrote as an example to show you. And all this is doing is using the year frac function, which is one that, it's just fun to say the name of that function. And it's just using as its inputs for start date and last date, start date and end date. It's using those two measures that I wrote, the first non-blank measure and the last non-blank measure. But I think the most obvious thing that you're going to want to do when you see something like this is you want to know, well, how much did we sell on that date, on the last sales date? So over here on another sheet, I have basically the same pivot table. I've selected a different product on this particular pivot table, but I have my most recent day sales measure already written here. So as long as we're comfortable that this is correct, and we'll validate that in a second. What this is telling us is that on July 31st, which was the last day we sold an AWC logo cap, we had $9 worth of sales. And this is a higher volume selling product. So looks like all of these are the end of the month date. So it's looking like we probably sell this product every day, if most days, if not every day. And so let's look at this measures formula. And it might surprise you, or it might not, depending upon how much you're getting used to the sort of the pattern here. But last non-blank can be used as one of the filter inputs to the calculate function. And just sort of like end of month returns a single day, last non-blank returns a single day, and that's going to be used. So basically the filter context for the calendar date column is going to be set to that last date, the last non-blank date anyway. And so that's pretty nice and convenient. But let's validate that this is correct. So for July 2003, the easiest way to validate this is to just put the date column on the pivot table. Okay, so this is saying that we've got $9 of sales on our most recent date, which is the 31st. So let's scroll down to the 31st here. And in the total sales measure column, we've got $9. And so that matches up here. And maybe that's just chance. Maybe we're getting lucky. So let's try a couple of others just to make sure. So we've got August 2003 is telling us 36. We go to the end, and it's 36. And we can keep going down with 36 again for September, and again 36, and then 72 here. This will be the last one I check. Okay, so we're feeling pretty good about that result. Okay, I'm going to take date off of here again so we get a cleaner pivot table. And so basically, I think this is the first instance that we've seen where I cannot replace a valid measure formula. So last non-blank, we've already written a measure that does this last non-blank of calendar date with total sale. That's exactly the formula we wrote on the other sheet. And that measure is available to us. So let's try replacing this with the name of that measure. Can we pass a measure as a filter input to calculate? So it's the last sales date. So that semantically, last sales date, well, the formula for last sales date is precisely that last non-blank formula that I just deleted. And I click check formula here, and it complains at me. It gives me the same error that I get when I try to compare to a measure in a simple, sort of as directly as a filter input to calculate. So the same reason why we had to use the filter function before, we're getting the same error message here. And so 9 times out of 10, the formula that defines a measure and the name of the measure itself are interchangeable. But this is a case where it's not true, because we no longer, one way to think of it is that last non-blank has a special, just like the all function and the DatesYTD function and the dates between function, all those functions we've seen, it has a special impact on filter context. And so it is allowed to be used as an input to calculate like this. But just the name of a measure would just return a date. And so measures themselves are not allowed, just like we saw again with the filter function example. We will unfortunately see a couple more instances of this where you can't reuse a measure formula that you wrote earlier. But I want you to understand that this is by far the exception to the rule, and not certainly not the common majority case. The only thing left to finish up with first non-blank and last non-blank is to revisit something that I did earlier, essentially, which is there's really kind of two aspects of it. The first one is that you can use the first non-blank and last non-blank functions. You can use them against columns that are not dates. So for instance, here I have a measure that is simply the last non-blank of the products key, the product key column in the products table, with total sales as the evaluate to see if it's blank or not input, which they just call expression. And so we'll see that I get 541, 602, 606, 491. Okay, and if I change this to 1, so rather than the name of a measure or anything or any other expression for that matter, well, 1 is always not blank. So before I might have described this as sort order, and again I tend to get confused when I'm using this function with things that aren't dates. But 1 is always not blank. So what's going to happen if I click OK now? Well, we get components. We get a 603 product out of components. And that's because we have products, we have component products in our products table that we never actually put in stores and we never actually sold. So when I set that last input to 1, then we can get that. And you'll notice that overall, 606 is the grand total. Now, so we're using last non-blank, and I think the important thing to know is that last non-blank is still going sort of for numbers, it's going in numerical order. So if I go to the products table and we go to the product key and we sort product key largest to smallest, we will see that 606 is the highest numbered product. And so last non-blank is going ascending in the sort order across that entire column. Now, if we wanted to use, let's say, well, what happens when we use it with text columns? So here I have a measure. I've got nothing on the pivot but the measure, and all it is first non-blank of the English month name column in the calendar table, and again using 1 as the blank or not blank expression. And given that we have sales in all months, I mean, I could certainly put total sales here and I get the same result. We're using first non-blank in this case, not last non-blank. And the month name that we're getting back is April, which is alphabetically first of the months. And this is I use this example because I want you to also know that when it comes to first non-blank and last non-blank, this English month name column, that's the one that I'm using the first non-blank function against. And it has a sort by column set. It is set to sort by month number of year. And we've seen that will impact the way that it appears on rows, columns, and on slicers and things like that. But the thing here is that it is not affecting first non-blank and last non-blank. So if it was, we would be getting January as our first non-blank. So that's a little bit of a divergence, not a big deal. It's just that first non-blank and last non-blank, well, the sort by column affects sort order when you show it somewhere, but it does not affect sort of like formula sort order in the sense of first non-blank and last non-blank.